Wanted to talk you through problem 11 in chapter 5. And this problem and the next one, in fact, have to do with internal rate of return calculations. And just before I dive into the problem, I want to mention that the internal rate of return on training for physicians, training for lawyers, training for MBAs, etc., is an important measure because by and large we'd expect the internal rate of return, and if these labor markets are competitive, we'd expect the internal rate of return to roughly match market interest rates, which are a reflection of people's overall time preference. And we generally find that to be true for lawyers, as the text indicated, and even for MBAs. Of course, there's a lot of variability within each category. So if you're a star lawyer or a star MBA, you're going to make a much higher rate of return than if you're mediocre at either one. But on average, those internal rates of return are pretty close to the long-run market interest rate. And we find that, just to remind you about the reading, we find that for physicians that's not true, that there's extraordinarily high internal rates of return, and this indicates that there are some barriers to entry, keeping physician wannabes out. And then we look closely at the institutions, we find, oh yeah, there's plenty of barriers. Anyway, on to the problem. We see this fictional table of returns to various occupations. And notice they've simplified it. In real life, we have returns over a 30, 40-year working career. Here we've just boiled it down to just 4 periods to simplify. And then problem A talks about discount factor. Problem B, of course, asks you to calculate the equivalent discount rate. So that's an important distinction. Interpret this assumption that the discount factor is 0.95. That simply means that $1 tomorrow is worth only 95 cents today. And $1 two periods away from today is going to be discounted twice, 0.95 times 0.95, otherwise known as 0.95 squared. So it's 0.95 to the T in general is the discount factor for period T. And we need to take into account people's time preference because $1 next year is not the same as $1 this year for any of us. But of course, each one of us has a different time preference. Some of us are very forward-thinking, and some of us are not. And I've used the ant and the grasshopper parable to illustrate the difference, as did Aesop. And students look at me blankly, and I realize that Aesop's fables aren't as popular as they used to be. I'm just going to take a small digression to give you a chance to read that ant and grasshopper fable. One moment. Okay, here's that ant and grasshopper fable. It's not long, and if you haven't ever read it before, pause it and read it now. Basically, the grasshopper is living for the moment, the ant is forward-thinking. So we start off in this problem with a look at an ant's decision-making process, and later in the problem we look at the grasshopper's decision-making process. I don't know that any of you had a problem with part B, but we know that the connection between the discount factor, D, or delta, actually, if I were let me try to draw that Greek letter. Delta would be the Greek small letter D, delta, and that equals, that's the discount factor is delta. That's just the ratio of $1 tomorrow to $1 today, or $1 next year to $1 today. That's equal to 1 over 1 plus R, and that's a fundamental relationship in finance, is that the discount factor is equal to 1 over 1 plus the discount rate. Anyway, you can manipulate that expression to find that R is equal to, what is that equal to? 1 over delta minus 1. Anyway, you can do that math and find that the corresponding discount rate. Anyway, the next part of the problem asks us to calculate the net present value. And we calculate the net present value because as we evaluate the returns or the lifetime earnings of ophthalmology, being an ophthalmologist and being an accountant, we have to take into account that gains in period 0, or that's today, are not the same as gains in period 1, period 2, period 3. Those are, because they happen at different times, they mean different things to different people. And so we have to correct for that by putting everything into terms of comparable dollar units. They don't give us units. Maybe these are dollars, maybe they're thousands of dollars, whatever, tens of thousands of dollars. But the point is, we have to be able to compare apples to apples, and to do that, we have to put everything into common units, and that's what the net present value calculation is all about. So I'm going to go to, I do these things in a spreadsheet. It's vastly easier than by hand, so I'd have a tablet or a laptop with you if any problem like this is coming up in class. All right, so what I've done is simply put the information we're given into a spreadsheet, and I'm just going to walk you through. I've got the answers already here, but here's this first upper portion. I've just entered the information in the table. Hopefully I've done that correctly. Returns to ophthalmology, returns to being accounted. And here I've calculated the discounted values, and all I've done is, well, you can see that I've highlighted this cell in the associated formula, just taken the discount factor, put it to the power of the period that we're in, and then multiply that. That's going to give me the discount factor appropriate to the time period, and then I multiply that to the nominal value. For ophthalmology, gets you here. For accountant, turns that 5 into 4.287, given this discount factor. So that's what I've done to convert each period's units into comparable units, and then I can just simply sum them up. So I've just showed you that column to the right, where all I did was summed the common discounted values, and I get these two answers, and we see that for the person with this discount rate, the net present value of returns to ophthalmology is greater than the net present value of the payments out to an accountant, and for this person, they'd rather be an ophthalmologist because it's a higher paying profession given this person's discount rate. That gets us through part C, I think. Let's just pause and go back to that problem so I know where I'm going. Let me beat this problem dead. So this part D asks us, will the internal rate of return for becoming an ophthalmologist as opposed to an accountant be greater or less than your answer to exercise 11B? And here, the intuition being exercised by this question is, or developed perhaps, it wasn't there before, you would think this one through, but hopefully it is thereafter. If the net present value of the calculation is positive, is greater for one profession than the other, it means that the internal rate of return is greater for that profession than our discount rate. If it were less than, then when we did the net present value, we would have come up with the result that the returns to being an accountant were better than for being the ophthalmologist. So anytime you come out with a greater net present value of one alternative compared to another, you're going to be finding that the internal rate of return to the preferred profession is greater than your own personal discount rate. So the problem goes on to part E, does the same exercise as I did for C, now for the grasshopper, and then the hard part of the problem was F, and as you know, problem 12 asks you to go on with F. But let me first just beat part E dead, and then we'll move to F. All right. For part E, all I did was repeat the exercise that I did for part C, as I recall. And I just changed the discount factor from 0.95 to 0.6, but you can see that the formula has remained the same, as of course it would. But now, when we get to sum those returns, because we're discounting future periods so heavily, oh yeah, now we see that the lifetime returns to accountancy is 6.32 compared to 1.79, and the grasshopper is going to go be an accountant. The early career earnings are high. You don't have to spend a lot of money and a lot of time in med school or optometry school, and that's the path for the grasshopper.